Hello students, Dr. K here. I want to make sure that I make a quick video, hopefully 2-3 minutes, really nothing more, just talking about the lattice method for multiplication. And it's a method that we like. I like using this method just to reinforce the math facts. The algorithm is not very efficient. When we multiply in a crunch, we really use the traditional algorithm or we use a calculator. But I like this method because it reinforces two reasons. Number one, it reinforces that multiplication is just repeated addition, number one. Number two, it gives some historical aspect of why we do this, how different civilizations multiplied, Napier's bones, and all that. And maybe number three, maybe there's a third benefit, even though as I said two, maybe there's a third benefit, is that it reinforces the multiplication facts in students. Let's keep going. 790, so 790 times 153. So 790 times 153. Three-digit number by three-digit number. So the grid is a 3 by 3 right here with diagonal lines. Sometimes I even like to put a diagonal line here and here at the end, representing different shoots. Okay, let's start. 790, we write it on the top, 790. Again, makes no difference whether we do it this way or the other way, meaning we can do 790 on the top, 153 on the side, or we can swap them because multiplication, the order doesn't matter, or we could do 1 and then we do 153 here. Of course, if we swap them, we should get the same answer, and that's a good exercise for the students. Let's start. Now we multiply. This is where, remember, our math facts. We can go every single cell, every one of these cells, we write the product of multiplication of nothing more than the digits. So, for example, let's start with here, top left. 7 times 1. 7 times 1 is 7. We know that. That's our math fact from the times table. We know that we could do a 0 and 7 to represent that. We can go down the column, we can go over the row, we can zigzag, either way. I see a 0 right here. 0 multiplied by anything is a 0, so I know that whole column is going to be zeros. Because really, 0 times 1 is 0, 0 times 5 is 0, and we just have to represent it as 0, 0. Or we could leave it blank. I like to write the zeros just to make sure that I didn't forget doing it. And students have different preferences. Okay, 9 times 1. The product goes here. 9 times 1. 9 times 1 is 9, so that is 0, 9. Let's keep going. The middle. 9 times 5. 9 times 5 is 45. Last I checked, 45. 9 times 3. 9 times 3, 27. The 2 goes on top. The 7 goes on the bottom right here, and that is 27. Let's keep going. We're almost there. 7 times 5. 7 times 5, 35. 7 times 3, the last one, 7 times 3, 21. Lucky blackjack, lucky 21. Okay, now we just do the number shoots. So we have these number shoots, number passages, and these align with place values. So the 1's digit is going to be here. That is a 0. The 7 comes down here. Here we just keep adding. There's no carry. We just keep adding zeros, 5, 2, and 1. That's an 8. We keep going. 9, that makes a 9. So that's 18, 2, that's 20. So we write a 0 here, and we have a 2 to carry. We can carry the 2 at the bottom. I like to carry the 2 at the very top, just to make sure that I show that I'm carrying it. And now it's what? 7 times 3, 7 plus 3. We're just adding now. That's a 10, a 2, that's a 12. So that's a 2, and I carry the 1, and a 1 comes down. And now the answer is, according to this, the lattice multiplication method, 120,870. So many math conversations can come out of this. Did we really need to include that 0? Or could we have just intuitively done the work without the 0 and added the 0 later? Great question. Students will come up with all sorts of configurations. Why are we doing this? Is this even helpful? Should we use calculators in math class? Should we not use calculators in math class? Should we use slide rules, abacus? all the different historical ways that mathematicians used in history. All these are valid answers. I like the lattice method. I like it because it reinforces students' skills. I like it because I like the three mentions that the two and a half reasons I gave in the beginning of the video. I like this. This is fun. I don't mind doing this in math lab, and math is fun. Math is fun. We should do this more. Bye.